Okay, wonderful. And now Marco from Kong is going to join us. Fantastic. Good to see you again, Marco.
Good to see you. Can you hear me well?
Yeah, sure. So let's see, your slide decks are up and ready to go. Let's go with zero trust, important topic when you're talking about data. Let's get into it. Thanks.
Thank you. Thank you. Yeah, so today we're going to be talking about zero trust, which is a very important topic that everybody has to think of whenever they transition to microservices. My name is Marco Palladino. I am the CTO and co-founder of Kong. And in my capacity in this role, I work with enterprise organizations that are transitioning to microservices and want to implement a secure architecture for all of their applications. The thing is, services are becoming the backbone of every new digital experience that we are creating. If we look at the next 5 years or 10 years within our systems, we're going to be having more services, not less, that is going to be powering all the things that the organization and the business wants to do. These microservices are communicating with each other over the network, which is very different from the old days of, as we know, of the monolith. The monolith, everything was self-contained, but in microservices, that is not the case anymore. The network and these API connectivity is at the backbone of every new application that anybody in the organization is creating. But there is a big challenge. As we transition to microservices, of course, we get benefits like being able to deploy faster, being able to ship features and products faster, being able to run a more high available architecture that does not depend on one large monolith that can be distributed across the board. But then, of course, we also have to deal with all the things that the network puts us through. And one of them is security. As we all know, the network is by default unreliable. It can go down. It's not secure. By default, we have to put something in place to make it secure. And sometimes it can be slow. The performance of that network can be unpredictable in such a way that the end user experience becomes unpredictable. So when we talk about security and the security aspects of microservices, we must make sure that we can remove the concept of trust from our systems. Trust is exploitable. We cannot trust that whenever we receive a request from another service, the service truly is who they claim they are. There must be some sort of identity that certifies that. We must remove the concept of trust, hence zero trust, no trust. Zero trust security is a new pattern that allows us to implement this concept in a very easy way. And it also allows us to not only provide an identity to all of our services, but also being able to encrypt the traffic among the services. This allows us to better defend ourselves from external threats and internal threats. If there is a service that should not be making a request to another service, with zero trust, we can prevent that. With zero trust, we can apply sophisticated permission policies that determine what service is allowed to do what operation on a third-party service. Now, the concept of trust, it's not something that's unique to microservices. Whenever we travel, and we enter a new country, we have this concept being applied in our daily lives. Whenever we enter a new country and the immigration officer asks us to show proof of identity, we show them a passport. And the passport certifies that we are who we really are. It gives us a virtual identity that allows us to enter the country. Now, without the passport, the immigration officers would have to trust that we are who we claim we are. And that trust eventually will be exploited by a malicious actor that just wants to go through claiming that they are who they are not in real. And so the concept of trust itself, it's a weak point. And we must be able to do the same thing that we experience in our daily lives when we enter a new country, but with our systems. So how do we provide a virtual passport to our services? And then on top of these identities, how do we create permissions that allows different services to access other services and determines what operations we can perform? Essentially, we need these virtual passports. Now, this is quite challenging virtual passports for our services is typically being created by issuing TLS certificates that identify the service itself. And managing this entire TLS lifecycle can be quite challenging. We don't want the application teams to build any of this. We want the application teams that are focused on creating the ultimate product and user experience. We want them to focus about that. We don't want them to build infrastructure. And Zero Trust truly is part of the infrastructure. So we, as architects, really have to provide this type of infrastructure for the teams in such a way that it's just there and they don't have to worry about building it. Now, in a monolithic application, every resource that we create can be accessed indiscriminately by every other resource via function calls. So there is an object that can make function calls to another object, and by doing that, we can change the state, for example, of our resources. For example, this is a marketplace application. Think of something like Amazon.com. There's going to be resources encapsulated into classes, into objects that represents the entities that we want to interact with, the users, the items that we can search and purchase, the billing, and so on, the invoices. Now, typically, this means that the objects that we have are going to be exposing function. And if these function calls allow us to modify the state of our resources. Of course, we could be implementing some sort of package level visibility and accessibility. We can use function modifiers, public, private, protected, and so on. But quite frankly, in a code base like in a monolithic code base like this one, everybody that can access an object can potentially change the state of that object. Now, this is quite problematic because we essentially have no checks in place. Everything is one commit away from being potentially ruined for giving access to a third party to a function that they should not be accessing. Now, with microservices, we can actually improve the security of our systems. And this is a little bit counterintuitive. Microservices, it is true that they add the network, and the network by default is not secure. But we can secure that network. And once we do that, we are going to be having a better, more secure, ultimate application within our systems. Because as soon as we decouple these concepts into separate services and separate code bases, instead of having every resource in the same code base, now we have these ones being deployed and decoupled and assigned to individual components, each one of which exposes an API that now can be secured and protected with our API infrastructure, which means that with microservices, we can improve the security. And it's an opportunity for us to improve security because we can apply tighter controls to determine what can do what. In a microservice architecture, our resources are going to be interacting with each other via connections and requests that happen over the network. It can be REST, can be gRPC, can be really anything, any protocol or any transport that we want to use to enable this communication. But by default, decoupling our monolith to microservices doesn't really change the situation. Without any other barrier in place, every service can theoretically consume every function or every other service. The communication medium has changed this time so that we can use networking software to secure how this communication happens, which is something that we could not do in a monolithic application. So in order to determine security rules over our API connectivity among all of our services, we must do a couple of things. First, we must set up permissions, and then we have to check those permissions on every request. Simple as that. So for example, we may want to check that the invoices service can consume the items service, but not vice versa. This is a very simple permission check that we may want to implement. And this check can be done by the services themselves. So if we ask the application teams, hey, can you check that this service can only consume that service? They're going to be building something. The problem is that whatever they're building, it's going to be fragmented across the board, and every team is going to be building the same thing all over again. We don't want them to do that. We don't want them to build security in the underlying connectivity infrastructure, but we want to provide something to them. But before we can even think about checking those permissions, we must have a reliable way to assign an identity to each service in such a way that we can build that permission in the first place. Identity is essential. Without an identity, there is no security. How can we apply a permission that determines the user service can do this or that if we don't know that that's really the user's service making a request? And so in order for Zero Trust to be implemented, we must assign an identity to every service instance that's going to be used for every request. The identity acts as the virtual passport for the request, confirming that the originating service that's making the request is indeed who they claim they are. And in order to implement Zero Trust, mutual TLS can be adopted to provide both identity and encryption to the transport layer. And because now every request carries an identity that can be verified, we can now enforce permissions in our services. Typically, the identity of a service can be assigned as a SAN, a subject alternative name, of the originating TLS certificate that's associated with the request. As it is the case of a Zero Trust security implementation by a service mesh like Kuma that we're going to be exploring in just a second. I have a demo today that I want to show you that applies Zero Trust across the board. So SAN is an extension of X509, which is the standard that is being used to create public key certificates. This allows us essentially to assign a custom value to a certificate. And in the case of Zero Trust, the service name itself can be one of these custom values. We can push the service name into a SAN field in such a way that when a request is being received by another service, we can extract this SAN field from the TLS certificate and the service name by doing so, and then verify, and then implement permission checks on top of that service name. So the service name, it is something that we can bake into the TLS certificate that's being associated with the request. Now, of course, maintaining a TLS infrastructure and lifecycle is quite complicated. We have to create certificate authorities. We have to rotate the certificate authorities once in a while. Then once we have the certificate authority, we want to be able to issue a data plane proxy certificate to every service and service instance that runs across the board, no matter what platform the teams are using. Because we want to be able to run this across Kubernetes. We want to be able to run this across the cloud, across VMs, virtual machines. It can be quite challenging. And we definitely want to provide these to the teams in such a way that they don't have to build it and worry about any of this. And this is where Service Mesh really comes into play. And today, I want to show you a demonstration of Zero Trust with Service Mesh. With Service Mesh, we can essentially provide all these network management capabilities for our API connections out of the box to the application teams. Whenever we want to implement Zero Trust, whenever we want to implement observability, whenever we want to implement reliability, self-healing of the requests, we don't have to ask the teams to build it for us. Instead, with the service mesh, they can consume these functions and become the users of these functions. So the architect would deploy the service mesh for the teams, and the teams get this out of the box. The service mesh works in a very simple way. There is going to be a data plane proxy. In the case of Kuma, that's Envoy. That's being deployed across every service and every instance of that service. And then Kuma itself is the control plane that manages this fleet of sidecar proxies that we run across the board. And because this is Kuma, we can support Kubernetes, but also VMs in a very native way. We can support one application, one cluster, or multiple clusters out of the box. Today, Kuma is a CNCF project. It's been used by more than 1,000 organizations to implement service mesh in production. As a matter of fact, today, Kuma, if you're ever purchasing a flight in the United States, you may not know that, but it goes through Kuma. It runs across both Kubernetes, VMs, every cloud. It supports multi-zone deployments that allow us to distribute the service mesh across multiple clusters, yet have one control plane to manage it all. Yeah, and also it allows us to support multiple meshes on top of one cluster, being able to support native policies for security, observability. It's a very simple to use product that allows us, among the other things, to implement Zero Trust. Now, when we talk about service mesh, we have to identify what are the pain points of service meshes. And service meshes typically are hard to use, they're hard to deploy, they're hard to manage. And with Kuma, we can very easily simplify all of this by providing an easier to use interface, by providing first-class support for VMs and Kubernetes, as well as by providing native support for distributed environments, which is not something that every service mesh out there does. By supporting the concept of having a global control plane that becomes the source of truth for our configuration, and multiple remote zone control plane, one for each zone that we want to support. Essentially, the system already has built multi-cluster, multi-cloud out of the box. Essentially, the global control plane is the primary control plane that we're going to be using for managing the service mesh, including the zero trust configuration. And we can deploy a remote secondary control plane in each cluster, each zone that we want to support. And automatically, the system will propagate policies from the global to the zone control plane, and also enable cross-zone connectivity automatically without us having to worry about it. Essentially, it creates this overlay across all of our services running across all these different platforms, as if they were running in one computer, but in reality, they're running in a distributed way. This is quite innovative in the service mesh landscape. It has been existing for a couple of years. And essentially, this architecture drives the adoption of Kuma because it really simplifies deploying a service mesh at scale inside of the organization. And then, of course, there is a GUI, there are CRDs for Kubernetes, there are APIs that we can use, there are policies for security, for observability, for traffic control, for zero trust that we can adopt, and out-of-the-box charts, 70 or 80-plus charts that we can provide to our teams. Now, before I jump into the demo, I want to show you a very simple policy for applying zero trust, and here it is. Essentially, in Kuma, we can create a configuration such as Kuma itself can either accept a certificate authority that we want to provide to the system, or we can ask the service mesh to automatically create a certificate authority for us. And then whenever we do that, the system is going to be automatically provisioning certificates to every service and automatically rotating them. All of this lifecycle, all of this propagation across multiple clusters, multiple clouds, the creation of the CA, the rotation of the CA, all of this, the rotation of the certificates, all of this is being done with this one policy. So we apply this one policy, and all of a sudden, we have zero trust enabled across the board. It's really that simple. And then, of course, we can apply permissions on top of that. So we can determine, okay, I want this system, this service to be able to consume that service or not, right? So we can apply sophisticated permission rules on top of the identity that zero trust gives us. Mesh is the enterprise version and supported version of Kuma being created by Kong, which on top of all of this also adds another concept, which is the concept of OPA, the Open Policy Agent support, that also allows us to implement even more sophisticated rules on top of the identities that we create with zero trust. With this OPA integration that Mesh provides, we do not need to use an additional sidecar for the OPA agent. Everything is bundled in the same sidecar that runs Envoy. So this also simplifies the operations of running a service mesh by an order of magnitude. And by default, it's OPA enabled. All right, let's go no further. Let me pull up the demo, and I want to show you something. So today I have the following configuration. I have the following service mesh. So I'm running a service mesh on Google Cloud across 3 different clusters. There is a global control plane running in this cluster. Then we have an east and west region. And I also run a service mesh simultaneously, the same one, on virtual machines on AWS. So what we're looking at right now is really a demo of a service mesh that runs in a multi-cloud, multi-cluster capacity, and it's a hybrid, VMs and containers. We can connect to the global control plane to see what is the status of our resources. And once I do that, we can, first and foremost, we can explore the namespaces that we have. Let me make this bigger. we can explore the namespaces that we have, and we can see there is a Kong mesh namespace. And then if I do fetch all the pods in the Kong mesh namespace, we see our global control plane. So this is the source of truth. Let me port forward the global control plane on port 5681 so we can access the mesh. By default, the mesh also provides an API. So we can, everything that the GUI can do, the API can do. So we can automate all of this. But then if I go on /GUI, we can go and fetch the user interface of the service mesh. So today, we're running this as service mesh across 3 different zones. We're running it across EC2, across East, and GK West. And we do have some services running. This is a very simple demo application. Essentially, we can show a front end that allows us to increment a counter on Redis. And so if I go on the demo application, this is exactly what the demo application can do. Now, I have a Redis installed in every zone. So I have a Redis installed in all of these different clusters and AWS in such a way that we can apply Zero Trust security, and we can now see not only the certificates being created, but we can also see cross-zone communication happening out of the box. So let's go ahead and pull up the policy that we want to apply in order to enable Zero Trust. So I'm going to be taking the same policy I showed you a second ago for mutual TLS. We can essentially secure our default mesh with mutual TLS. We can automatically create the certificate, but you can also integrate this with Vault or provide your own certificate authorities. And then we're going to be automatically rotating our certificates every day. So I'm going to be creating the command that I'm going to be executing in kubectl. So this is the command that, I'll put some syntax line, that we're going to be executing. And I want to show you what happens when I do that. So I'm going to be auto-incrementing the traffic, and I am going to be applying Zero Trust on top of my distributed service mesh to the global control plane. The global control plane will now create the certificate authority, propagate it across every remote zone, then issue certificates for every data plane's replica, rotate that certificate every day out of the box, and all of a sudden we can see traffic going from Redises across multiple clouds, multiple regions, hybrid VMs and containers. And not only that, all of this is now fully secured with TLS. So we can see, if I select my default mesh, which is the one that I'm using, we can see which data plane proxies have the certificate authority enabled. And if you actually go on the individual data plane proxy, we can also see the certificate insights, and we can see that the certificates were created less than a minute ago. Now, on top of this, we can apply sophisticated traffic permissions that allow us to determine what the system can do. So today we do have a permission that essentially allows to make requests across from every service to every other service. But if I go ahead and remove this permission with kubectl, so delete traffic permissions, we are going to be essentially shutting that down. So we can now control permissions on top of our cluster by essentially using the service mesh policies and entities. So this is a very quick demo that I wanted to show you about Zero Trust and service mesh in a nice presentation. Today, we looked at the fact that our organization is going to be having more and more connectivity. More connectivity creates a security problem that we can solve by removing the concept of trust from our systems with Zero Trust. And we've seen how we can use a service mesh, in this case, Kuma and Kong mesh, to implement Zero Trust in one click, really, literally one click across the board in multi-cloud, multiple clusters, hybrid VMs and containers across the entire organization. This is a very small presentation. There is a lot more to this, of course. It's a starter, if you wish. You can learn more at kuma.io, or you can get in touch with Kong at konghq.com/kong/mesh if you want to learn more about service mesh. Well, thank you so much.
That was fantastic. Thank you, Marco. Really great to see some demonstrations there of how people can just start getting into this and give it a try. A really important issue to be incorporating into your stack. Okay, great. Thanks very much. I'll invite you to leave the stage. Thanks.